4.5, which deals with some things like confounding and control groups and like what a baseline is. Decided instead of going back over the check understanding questions first, I want to do the examples out of the book first, and then if you're still confused, you can come back to the check understanding questions after that. So you thought that'd be more helpful since most of you were here for the check understanding stuff. All right, so what we're looking at here is some doctors who are participating in the study. So there's about 22,000 male physicians. They're either assigned to take an aspirin or an aspirin placebo, and then they were also asked, or they were assigned to take a beta-carotene or a beta-carotene placebo. They were followed for several years to see if they had a heart attack or got cancer. So seeing if the aspirin helps protect against heart attacks and seeing if beta-carotene helps prevent cancer. So why was it necessary to perform an experiment rather than an observational study, which was just asking the doctors, hey, do you take an aspirin? Hey, do you take beta-carotene? Hey, did you get cancer? Do you have a heart attack? So why do we need that? If we're going to show causation, we need to run an experiment. So in order to say taking aspirin causes a reduction in heart attacks, or to say taking beta-carotene causes a reduction in cancer, we need an experiment. An observational study could suffer from confounding. Some other variable might be getting in the way. That maybe those doctors that are taking the beta-carotene and the aspirin are also running every day and eating lots of fish, or drinking lots of antioxidants, like other things that could help heart attacks and cancer, things like that. So we got to run an experiment for that and start controlling some of those other variables. Identify the 4 treatments in the experiment. So this is just, did they get an aspirin or did they not, right? Did they get a beta-carotene, which I was going to say is BC from now on. So maybe one of the treatments is they got an aspirin and a beta-carotene. Maybe the second treatment is they got the aspirin, but they got the beta-carotene placebo. Then maybe the other one is they got the aspirin placebo, but they got the real beta-carotene. And then maybe the last one would be that they got both placebos. So those are the 4 treatments, 4 possible groups they could have been put into. And then explain the purpose of the control group. So the control group in this case would be that group that got the placebos. So again, what a control group does is it provides a baseline so it provides a baseline for what proportion or what percentage of these doctors would have a heart attack or develop cancer without taking these treatments, without taking these medications. So the idea is like, say that 20% of the control group gets, has a heart attack or gets cancer, but maybe only, 15% of the people in the aspirin group, aspirin, placebo, beta carotene, they only have, only 15% of them get a heart attack or cancer, and maybe only, 13% of the people in the aspirin and beta carotene placebo group have a heart attack or have cancer, and then maybe only 7% of the people that are taking both have heart attack cancer. It's like, it allows us to have those changes and see which one is the most effective, whatnot. So give us as something to compare to. So again, if it's like 20% have heart attacks or cancer here, but then 20% also have heart attacks or cancer here, and then down there like here 11%, and this one's like 9%. Like, so maybe like doing this really has no effects. Like, well, there's no point in taking just beta carotene. Like, something going on there. So it just allows us to eliminate things or see which one's best. Maybe doing this like went up. Like, maybe it was 25% of these people had like. It's really comparing like, oh, right, I'm gonna stop taking beta carotene. That's having it's increasing something. So things like that. Gives us a baseline, something to compare to. So, all right. Hopefully that helped. Be good. So here we have a study, 4,700 children, hospital whose mothers smoked during pregnancy were more than twice likely to develop ADHD as children as those whose mothers had not smoked. Based on that study, it is reasonable to conclude that mothers smoking during pregnancy causes an increase in ADHD in her children. Explain reasoning. So, as likely as that might seem, we cannot say this. It's not reasonable because this is not an experiment. This is only an observational study. They just asked the women if they smoked or not, and then they just asked the women later if their children had ADHD. We need an experiment in order to show causation. So an experiment would be needed to show that a mother smoking during pregnancy causes ADHD. In her children, or causes an increase in ADHD chance in your children. Since it's an observational study, it could suffer from confounding. So there could be some other link here that we just aren't aware of that's actually causing these things to happen. An experiment would help us figure that out. All right. Next one here. So we have researchers have had 186 students take part of an experiment, so that's important. While students were watching video, they were given brownies to snack on. Unknown to the students, the size and number of brownies differed from student to student. 3 different sizes, 4 different quantities. Researchers measured the total weight of brownies consumed and whether or not each student finished. So list the explanatory variables and the number of possible values for each. So explanatory variables are the different sizes. And so that had 3 different values, 16, and also the quantity. And there was 1, 2, 4, or 8. The researchers used every possible combination, how many treatments would be included. So since there are 3 here and there are 4 here, the part B would mean that there's 12 total treatments. So it's just multiplying the quantity of each length. So there's 3 times 4 is 12 total, and then 2 of them. So we guess part C is listing 2 of those. So just really kind of pick. So they get 1 8-gram brownie, they get 2 8-gram brownies, they get 4 8-gram brownies, they get 8 8-gram brownies, they get 2 16-gram brownies, they get 2 32-gram brownies. So it really doesn't matter which combination you get. So I could just say like, here's 1. So they receive 1 8-gram brownie. Or they could receive, I don't know, 4 32-gram brownies. So there's a whole, but obviously 10 more of those. So. And if that was me, I would eat all 8 of the 32-gram brownies because I love brownies. That's that. Last one here of these new ones. So many utility companies have introduced programs to encourage energy conservation. So this company is considering placing a small digital display to show current electricity use along with projected monthly cost. So there's 1 treatment. So they install a display, and I think it will show you monthly cost. Will those displays reduce electricity use? And another cheaper approach would be to just give the customers a chart and information about monitoring their use from the meter outside. Would that method work as well? They want to conduct an experiment to compare those 2 approaches with a control group that just receive information about how to monitor their electricity use, but no help in doing it. So they don't get the chart, they don't get the display. So why is it necessary to include the control group? So in order for an experiment to show changes, we need to know change from what. So the control group gives us the baseline. How much does just telling the consumers about energy consumption, actually change their consumption, right? And so if let's say that you're giving them information reduces their consumption by 5%. So there's our baseline, 5% reduction. Now we see, what if we give them a chart and this information, and see what their reduction is, and maybe it's 8% reduction, and then we give them the digital display and and with the projected monthly cost, and that reduces it by 20%. And so we say, wow, from the 5% reduction down to the 20%, it's 15% change versus the 5% to the 8%, it's only a 3% change. And they say, okay, wow, those displays really do make a big difference compared to the other things. Or if it was 5% reduction, and then 8% reduction, and then 9% reduction, only 1% more for us spending all this money to put in these displays. Like, oh, it's not really not worth it. We should just give them charts instead. It's a lot cheaper. Like, so we need a comparison. Or if it was like 5% and 6% and 7%, like, and they were like, oh, it really didn't change much at all, only 2%, and we have to spend all this money. Like, it's not even worth it. Like, so we need something to compare to. So, so the control group gives us a baseline on how much energy consumption can be reduced. Without a digital display or chart being provided. And that baseline would allow us to compare those reductions to something. The reduction in energy consumption provided by the display, digital display. Or the chart. So, need that baseline. We need a comparison, a starting point. So, remember the one from the lesson was that how much did the guy's beard grow with the oil versus how much it had just grown on its own. So that's the end of like the new examples. If that helps at all, I'm gonna go back and do the check understanding if you didn't miss those in class or you need to hear those again. So if you want to stop now, you can.